Today I'm going to be talking about the difference between salts and how to determine if when a salt breaks down, if it's acidic, basic, or neutral. So I'll start with acidic. If the salt produces the conjugate acid of a weak base, the solution is going to be acidic. So I just have the definition up here at the top for you. So I started with a compound, you can see, and I reacted it with water. For me, it's easier to write water as HOH, so you can see how those are going to break apart. So if you remember, a conjugate is basically just saying that it's going to donate or accept a hydrogen ion. And you can look at all of these as just double displacement reactions. So we're going to start with our iron right here, and that's the cation. So we'll give that a positive charge, and that's going to react with the anion of water. So water right there is the anion. That'll get a negative charge. Over here on our reaction side, so there's our cation and our anion, and that's going to make our weak base. And we do the same for the next. So here's our anion and our cation. So negative, positive, opposites attract. So here's positive, negative. So just double displacement. So you bring them over here. So HCl, that's going to be hydrochloric acid. That's going to make our strong acid. So we can see we've got a strong acid, and this one's a weak base, but that's going to make this acidic. So when I first did module 4, I could work a lot of those problems and have it make sense in my head, but I watched one video that did this X method, and that really helped make it click for me. So taking the same products, FeCl3, reacting with water, and you basically just X them and see what you get. So I'm going to work a problem for you. So we will do NH4Cl. We're going to react it with water. So again, I do HOH. And then you're going to X. So right there. And then NH4 is going to X with OH. So you can see that my orange is HCl, which was that hydrochloric acid. So that's our strong acid. And this is actually going to make our weak base. So if you remember, NH4 is going to donate, and that's going to make NH3. So that's actually going to make a conjugate acid for us. So conj acid. So this will be acidic. So moving on to basic, I've got the definition for you. If the salt produces the conjugate base of a weak acid, it will be basic. So again, we can look at the double displacement, NaHCO3 plus water, double displacement right here. We can see the cation reacting with the anion, cation, anion. So this one actually does form a conjugate acid. So right here, that's actually its conjugate acid. This will be basic. We do the X method again. I've got different products and reactants down here. So K2CO3 reacting with water, XM K2OH, that's going to be a strong base. HCO3 is a weak acid, so this is basic. If I do another example, I can do KFHOH cross so KOH, that's going to be a strong base, and that is potassium hydroxide. Forgot my orange line. HF is just a weak base, weak acid. So we can see that this is basic. And you can do this X method with any solution in water that you want, and it will work out to see how your salt is going to be acidic or basic. Moving on to neutral, your definition: if the cation and the anion of the salt is part of a strong acid or a strong base, it will be neutral. So here's our double displacement, KClO4 plus water. That's going to break into our strong base, strong acid. So KOH is our potassium hydroxide. HClO4 is our strong acid, that's perchloric acid. So strong and strong, that's going to be neutral. An X example up here, RBI is the strong acid, we're going to X them first. RBOH, that's going to be a strong base. HI is going to be your strong acid. That makes it neutral. Showing another example, KBr with water. So KOH is our strong base. And HBr, that's hydrobromic acid. That's our strong acid. You can see this will make a neutral solution. So for me personally, I think doing this X method is a little bit easier to figure out if it's acidic, basic, or neutral. And looking back at all of these examples, you don't have to have a conjugate acid or a conjugate base. Basically, if one of them is strong. So right here for this example, you can see you have a strong base, a weak acid. The strong is going to overtake. So this is a strong base. This is going to be basic. Up here, weak base, strong acid, strong. The strong is going to overtake. So this is going to be an acidic solution. So I hope this helps you guys. If you have any questions or you want me to do some more of the X examples, let me know and I'd be happy to upload a couple more examples for you guys.